A warm welcome of the graduating student in third semester who are pursuing the in graduation in mathematics. So in graduate third semester, what the paper you have? I am listing here. Then we will start the one paper from one of these. Here the first paper is there are three papers. One is real analysis. Second is modern algebra. Basically, group theory. Group theory studies partial differential equation. And its application. Here there are three jobs. That is 301, 302, or 303. So from this paper, I am going to start the partial differential equation and application. So let's proceed. The interesting topic of the differential equation. Yeah, I am erasing it. So first of all, what we will learn in this chapter, or what is the main concern of this chapter. First learn the definition of partial differential equation. Second, order and degree of relief. Third, type of partial, along with some notation. Type of partial differential equation. Fourth, formation of partial differential equation. Fifth, various steps. Fifth, we will learn Cauchy integral service. Fourth, Lagrange equation. BTec. There are many topics what I have will be covered. That I think that will be the first unit. First, there what are topics that I remember. I have a syllabus, so I will from the syllabus I will try to cover it. First, we will see look the definition of partial differential equation. So let's start. What are basically partial differential equations? If the function, suppose z equal to x plus y, we can say that z is the function of xy, z is the function of xy. Basically, when what happen in a ordinary differential equation? There are one independent variable. There are one independent variable, then we can differentiate with respect to other there, or basically we differentiate other. If when there are more than one independent variable, then they are changed with along with their dimension. We can along with the dimension we can say that the partial derivative derivatives occur, then we can say that this is the partial differential equation. When we differentiate it term by term, if we differentiate z with respect to when if the x and y are two independent variables, if we want to if we know that z is changes along with x and along with y, then we can cannot differentiate along one. So basically, what can I do? Basically, if z is changes along x, then we can say that x. Then there will be the what remaining other variable. When we differentiate a function, if suppose z is the function of x, y, when we differentiate z, f of x, suppose I will take the question from z equal to x plus y. If this function, when we differentiate the function z with respect to x, z by x, then what the other function have, that will be assumed as a constant. So if we differentiate x, that will be x, and if we differentiate z with respect to the function which I am differentiating with respect to, then beside this the other function will be taken as a constant, so there will be the constant. So basically, differentiation like this. An equation containing more than one independent variable independent. We can say that this is the independent from the other. When we differentiate z with respect to that is free from y, so we can say that we have an independent partial derivative. Why that is called this is a partial derivative? Because we differentiate only, we have a function as z, x and y, we only differentiate with respect to the other, we left the other, so this is basically one-sided, so one-sided you can say partial derivative of course partial derivative of unknown function of true or null variable is known as partial differential equation. So basically this is the equation. If I have it taken as z equal to x and y, what basically the question definition is concerned about, I am taking if z is the function, I have also discussed the if z is the function of x, y, when if beside these two variables, if I take it more than this, if I take z equal to function of x, y, z plus w, then if we can differentiate with respect to the four variables in four times, then that will be the partial derivative. If we differentiate z, dz by w, the that part will be taken as a constant, that will be 1. If we differentiate the z by w equal to x, from beside the x, what the other that will be taken as constant. So x plus what will be this I am taking. So dw d by dx plus x plus y plus z. So if I differentiate w by del x, w by this, in a differential equation, partial differentiation, we taken as in partial differentiation, besides the function which we are differentiating with respect to that aspect, then it is beside this other function taken as a constant. If I take in del w as a constant, then it will be 0, that will be 0, that will be 0, that will be 0. Okay? There will be 1. So there has the basically consistent. Basically, definition is about an equation containing more than one independent variable. Here I have more than one independent variable. If I have taken x equal to y, this I have taken x equal to y. If suppose if I take z equal to x, then if we differentiate z by del x, that equal to basically 1. So that's the same as d by dx z and dx equal to 1. That's a partial differential equation. One case that are common, that when we taken as 1, then the function is same as ordinary differential equation. Part 1 independent partial derivative or function 2 or more are variable. Here I have taken two variables. Here I have taken more than two variables, and the partial derivatives are occurring in 4 times. So this type of equation are called partial differential equation. So that's about the definition. Then we are proceed the order of a differential equation. Order of a differential order of PD. The order of partial differentiation equation is the highest partial derivative occurs in a partial differential equation. Suppose if we differentiate z, suppose here I have a question on differential equation dz by dx plus y equal to 1. Here the derivative are occurring this for differential equation 1 time. So basically the order equal to 1. If we differentiate, suppose if like that question dx square dy by dx d plus y equal to 8. So here the differential equation, then the derivative highest partial derivative occurs in 2 times. So the order is basically 2. Order is 2. If we differentiate that, if we say that d cube by y dx 1 minute dx so here the partial derivative will occur in 3 times, so that order is 3. Now degree. Now I am going to discuss about the degree. If you understand that, proceed further. Degree of partial differential equation. The highest or highest order derivative partial derivative occurs in a partial differential equation. Partial differential equation after in rationalizing or that is free from radical sign. So order is basically the highest partial. The order, what is the order in the highest order partial derivative or occur in a partial differential equation after in the radical rationalization or free from the radical sign. So here I am explaining what is this happening. So if suppose here if I have a taken a question dz by dx plus y equal to 1. The highest partial derivative, here the differentiation is occurred partial 1 time, so the degree is 1. If I say suppose if I square this equation dz by dx plus y, suppose equation is like this, we cannot say this is the order is 1. So we cannot say this is the, if we look at the differential equation, then we see that there is 1, then the order is 1, so we cannot say this is the order. So basically we have to expand this equation, then we can say that if we expand, that will be the del z by del x square plus y square plus 2y del z by del x equal to 1. Here if you can say the highest order, that is here the order is 2. Yeah, order is 2. Yeah, by using the a plus b square formula, a plus b square formula, we have write it a square plus b square plus 2ab. We have written it. So here from this expandation, after the expanding the differential equation, we see that the order is 2. Highest order is to show degree equal to 2. Here the order, basically the order is 1. Basically the order for fraction, all type of fraction. So order is degree is 2. Here I am taking a question. So dz by del x plus y by 3 by 2 equal to 1. So what can you say that the order is 2? What type of order is there? Order. What is the order and what is the degree? Now I can say if their order equal to 1. Order is 1. There is no confusion because this equation has no more differentiation, more derivative along with more derivative. So we can say that order is 1. Now here the power is a fraction. So what can I do? We can expand it. We can remove the square or root from this left hand side. Eh? What can I have to do? So basically if we squaring both sides, then that will be 1 square. So now here I am expanding this y cube plus 3 z by dx square y square 3 d y square dz by dx plus minus 1 equal to 0. Here you can say that there is a order after this is the, we can say that inside the bracket there is one derivative, then this is the multiple of 3. Basically del z by del x cube means dz by del x into del z by that is 3 times. So basically this type of equation we write it, this type of equation here. So we can write it x cube. So the order is degree is 3. So basically here this is there happen what in a algebraic equation happen. So basically here the highest from this equation the highest order is 3. So degree is equal to 3. So now what is the degree of equation? You can comment out dx upon 5 by 7 3 by 2 del z del x 2 by 8 dz upon. You have to comment out what is the degree and order of a partial differential equation. So for first video I think that will be for the first video, then next video will come. So stay tuned. Thank you for watching.